Oh, welcome and thank you for joining me. In today's lesson, we'll be introducing polynomial inequalities. Throughout this lesson, we'll review set notation, interval notation, solving linear inequalities, and solving double linear inequalities. These concepts will provide the foundation we need before we begin solving polynomial inequalities. Before we start, let's briefly review how we solve polynomial equations. To solve a polynomial equation, we set the function equal to 0. Our goal is to determine the value or values of x that will make the equation true. In other words, we're looking for the values of x that make the function value or y equal to 0. Now, I'd like you to think about this question. Where on the graph of a polynomial function do we find the points where y equals 0? Well, these points would lie on the x-axis, and we call them the x-intercepts or zeros of the function. Since we have already studied polynomial functions, we know that a polynomial can intersect the x-axis at 1, 2, 3, or even more points, and some polynomial functions may not intersect the x-axis at all. This tells us that the polynomial equation may have one solution, two solutions, three solutions, or several solutions, or even no real solutions. The important idea to remember, though, is that a polynomial equation always has a finite or a discrete number of solutions, and its solutions are individual values of x. So why are we reviewing polynomial equations? Well, the reason is that the process of solving polynomial inequalities is very similar. The major difference is that instead of finding the zeros of a polynomial equation, we are trying to find the values of x that make the function either positive or negative. Rather than asking f of x equals 0, this is where f of x equals 0, we will be solving inequalities of the form f of x greater than 0 or f of x less than 0 when zeros are not included, or f of x greater than or equal to 0 or f of x less than or equal to 0 when zeros are included in the solution. Now, let's look at the graph shown here. Notice that the polynomial function will cross the x-axis at 3 points. Therefore, the corresponding polynomial equation will have 3 solutions. These solutions can easily be listed because they are individual x values. Now, suppose that instead we want to determine where the function is negative. The answer to this function is lying under the x-axis because this is where the y values of this function are negative. Notice that the graph is below the x-axis between x equals negative 2 and x equals 0. And that means that every x value between negative 2 and 0 will make the inequality true. Now, think about it. How many x values are between negative 2 and 0? There are infinitely many. Clearly, it would be impossible to list every one of these values individually. Instead, we describe the entire collection of numbers by using the set notation or interval notation, which is something that we are going to learn today. We have already used set notation in previous grades to describe sets of real numbers when we describe the domain and ranges of various functions that we have studied so far. And today we'll learn interval notation, which expresses the same information in a more compact and efficient way. In fact, interval notation is the notation most commonly used when writing solutions to inequalities. Before we begin solving polynomial inequalities, let's review how these two notations work. When writing solutions in interval notation, in set notation first, we follow 3 basic steps. Step number 1, we identify the lowest and highest boundary values of the solution. Then we write the variable, usually x for the domain or y for the range, right in the middle between the boundary values. And then we use appropriate inequality symbols to describe the interval. Now let's compare with interval notation. In interval notation, the type of bracket will tell us whether the endpoint is included or not included. Around parentheses, means that the endpoint is not included. A square bracket means that the endpoint is included. Notice the example shown in here. What we have here is the number line, and we see that on one endpoint we have an empty circle and the other one is a filled circle. What that tells us is that all the values of x between the empty and the filled circle, which we are going to call by the letters a and b, are part of this interval, but a is not included, whereas b is part of the set of numbers. In set notation, we would open up parentheses or the squiggly parentheses and write x is any real number, xer, x belongs to the set of real numbers. This line indicates or means such that, and then we write a, which is the first endpoint in the set of numbers, and b, and in the middle we write x, and then we use the inequality symbols accordingly, so greater than for a and less than or equal to b. In interval notation, this collection of numbers will be written as x belongs to, or xe. We open round parentheses and write a, that's because a is not included, and then comma, and then we write the other endpoint, which is b, and add a square brackets on the side of it. Now, let's begin with our first example. We are going to look at examples where we have to convert the given set notations into interval notations. If you were to describe this set of numbers in the first row, we're going to say that x is any real number such that x is greater than -4 and less than +4. So greater than the lowest and lower than the highest. So we're going to say that in this case, x is between -4 and 4. If we were to write this in interval notation, we'll simply write xe, and since the numbers -4 and 4 are not included in the set, we're going to use parentheses, round brackets, and we'll list the numbers -4 and 4 separated by a comma. Now, it is very important that whenever we mean to describe a set of numbers between -4 and 4, we have to write x and then the symbol that indicates belongs to. Because imagine if you didn't write this, this would look just like coordinates of a point and not like a interval or a set of numbers. Now, in the next example, as you can see, we have x between -3 and 2. So x is a set of real numbers such that x is greater than or equal to -3 and less than or equal to +2. So we're going to say that x is less than or equal to -3 and greater than or equal to 2. Or in other words, we can simply say x is between -3 and 2 with -3 and 2 included. Let me just resize this. Now, in interval notation, we would write this as x belongs to the set or to the interval. Now, since we have -3 and 2 as endpoints, we'll start with the lowest, finish with the highest, separated by a comma, and we will include the endpoints because we want x to be equal to each of these values, and we'll indicate this by square brackets in interval notation. Now, next we have y, any real number, such that y is between -3 or equal to -3 and 2. So y belongs to the set of real numbers such that y is greater than or equal to -3 and less than 2. So we're going to say that y is greater than or equal to -3, and in the meantime, simultaneously less than 2. So in interval notation, we are going to simply list the two numbers, negative 3 and 2, separated by a comma. So negative 3 and 2 separated by a comma. X belongs to the set of these numbers, and now we have to pay attention to brackets. We want negative 3 to be part of the set of numbers, part of the interval, so therefore we're going to use square brackets around negative 3, and we're not interested in including the value of 2 in it, so that means that we're going to put round brackets around it. Now, in the next example, we are given sets of numbers on a number line, and we have to describe them by using both set and interval notation. As you can see here on the number line, we start at 2 and we continue all the way to infinity. So number 2 is number two is marked by an empty circle, and we're going to say that is not part of the set. So we're going to open the squiggly brackets. X belongs to the set of real numbers such that, and 2 is the only boundary number. The other is infinity, which is boundless. So we're going to just write the number 2 in here, and we're going to say that X, so let's use X for all these examples, will be greater than 2 because all the numbers are to the right of number 2. Now, if we were to write this in interval notation, we're going to say that X belongs to the interval. So we're going to start with number 2, which is the lowest number in the interval or in the collection of numbers, and we're going to use round brackets around it because 2 is not part of the set of numbers, and then comma, and then we'll write infinity. Now, very important to emphasize is that whenever we involve infinity or negative infinity in interval notation, we will be using round brackets, and the reason why is because infinity and negative infinity are indefinite numbers. So they're not numbers on a number line that we can point at and then put a boundary to it and say, there, that's exactly where it is. Okay? Now, that is very important to remember. Now, in the second set of numbers described on this number line, we have the values between negative 3 and 2. So we're going to say that in this case, we have all the x values, all the real values of x, such that now we have the lowest value of x equal to negative 3, the highest equal to positive 2. X will be in between, in the middle. And now we're going to have to compare. Now, x is going to be greater than the smallest and smaller than the highest. So when we list the numbers actually in this specific order, so from lowest to highest, then you're going to use the inequality symbols in the same way, in the same format. Since we don't include the ends of the interval, then we're just going to leave it at this, so we won't include the equal signs. Now, in interval notation, this same set of numbers will be written as x belongs to, we're going to start with negative 3, comma 2, and then we'll place round brackets around these two numbers because the ends are not included. Now, this is a very interesting set of numbers. And what we're going to do is start off with XER. So the real values, all real values of x, such that, now, in this case, we don't have x between two values, so it's not x greater than or equal to the smallest and less than the highest. We have the values of x beyond this low value and beyond to infinity of this x value. So in this case, again, we can write negative 3 and positive 3. X is somewhere in between, and we're going to say that in this case x values will be even further left negative 3, so less than negative 3. Notice how this is going to change the direction of our inequality. And the x values will be greater than 3, so we're going to say greater than 3. And that's how you would write this in set notation. Now, one last thing we need to take care of is the fact that we do include this negative 3 in our set. So therefore, we're going to put an equal symbol in here. We're going to add an equal symbol in here. And then we're going to close the squiggly brackets. And now we'll move on to interval notation. So in this case, we're going to say that x is marked or is part of two intervals from negative infinity to negative 3. And I'm going to write this down actually, from negative infinity to negative 3. Remember round brackets, square brackets, and from 3 to infinity. So round brackets around infinity and around 3. So as you can see here, the set of real numbers is described by two intervals. And when we have two intervals, we join them together or we add them together. And the addition symbol when we add sets of numbers will be this U-shaped symbol, which stands for united. And we're going to write this as negative infinity, comma, negative 3 square brackets here around here, and then united by, we'll continue with the next interval, which is from 3 to infinity. So in this case, I would find this one a little bit more practical than this. But again, just to be consistent, we're going to continue using the interval notation when solving inequalities. Now, in the next set of numbers described in here, you see that we have all real numbers besides or except for negative 1. So in set notation, I would simply write this as x any real value such that x is different than negative 1. And in interval notation, we're going to mark two intervals. One starts at negative infinity, ending at negative 1. And the other starts at negative 1, ending to infinity, well, never ending. And these two intervals should be united with each other. And this is how we use interval notation, and I hope that this made sense and it was clear enough for you. We're moving on to another example. This time we are given the set of numbers described in set notation, and we have to graph them and describe them in interval notation. So x greater than negative 3. So first we're going to start with number negative 3, and we're going to find it on the number line, and we're going to place in here, we're going to draw an empty circle. That's because negative 3 is not part of the set. Now, the values of x greater than negative 3 will be to the right of negative 3, so in this direction. So all these x values will be part of the set that is described in here. And in interval notation, we'll say that x is any real number such that x is between negative 3, so brackets, negative 3 to infinity. Now, negative 3 is not included, so brackets, round brackets, parentheses. Next, we have any real number value, a value of x, such that x less than or equal to 4. So we have to locate x equals 4, positive 4, and we'll make sure this time that at 4, we're going to draw a filled circle. The x values are less than 4, which means that they'll be to the left of number 4. So these are all the x values that we want to include in the set, and this is how you describe this on a number line. Some people like to just draw an arrow in here, but when we use paper and pencil in class, I think it is more obvious when we use this symbol or this method of describing the numbers rather than a line, because the lines can overlap with a number line. Small detail, but important nonetheless. So when you write this in interval notation, then we're going to say that we're going to start at negative infinity, comma, and at 4. And number 4 is included, so we're going to place square brackets in there. Be very careful and write very clearly, and make sure that it is easy to tell the round from the square brackets on your evaluations. So now we have x values greater than negative 2, less than 3. So we have to mark both values. So negative 2 and positive 3. We want the x values to be in between them. So this is where all the x values will be. So we'll say that in interval notation, we have the numbers negative 2, comma 3, and we're going to use parentheses at both sides. Now, between negative 4 and 10, so x any real value such that x is greater than or equal to negative 4 and less than or equal to 0, 0, not 10. So we have negative 4 is included in the set, and 0 is also included in the set. So the x values are in between. So we're going to say that in interval notation, we're going to write negative 4, comma 0, and we'll place square brackets around both numbers because they're both part of the set. Next, we have x greater than negative 3, less than or equal to 1. So we have to locate negative 3. And negative 3 will need an empty circle. And positive 1, we're going to use a filled circle in here because it's part of the set. And the x values will be in between. So we're going to say that in interval notation, here we're going to have negative 3 to 1. Negative 3 is not included and 1 is included. Next, we have any set of real numbers such that x greater than or equal to negative 1 less than 6. So we're going to spot negative 1, mark it with a filled circle because negative 1 is part of the set, and positive 6, mark it with an empty circle, is not part of the set, and all the x values will be in between. And I think we kind of get the idea now, and we're going to say that x is between negative 1, comma 6. Negative 1 deserves square brackets, and 6 is in round brackets because it's not included. This is how we describe sets of numbers, and this is a very important skill we need to solve linear inequalities. So we will continue with solving linear inequalities and the process of it in the next video. And as always, thank you for learning with me, and bye for now.